write in this form. So that is integral 1 to 0. So you will get 3 minus 8 minus 6 x square, then you have minus 12, then 26 x dx varum. So that is minus 11 x cube by 3 varum, minus 12x plus 13 x square from 1 to 0. So at 0 it will be 0, then minus 11 by 3 minus 12 plus 13. So that will be equal to 8 by 3 when you simplify. So on this second curve you will get 8 by 3. And next we need to evaluate along BO. So along BO we have x equal to 0, so dx will be equal to 0. So integral m dx plus n dy will be equal to, first term 0, second term 4y dy matra varullu, and y will vary from 1 to 0. So that is 2y square from 1 to 0. So you will get minus 2. So therefore integral m dx plus n dy will be equal to, so you will have 1 plus 8 by 3 minus 2, so which is equal to 5 by 3. So that's what we got for the double integral also. So hence the theorem is verified. So now we will look at one more question. So the next question is, so use Green's theorem to evaluate integral over c 2x square minus y square dx plus x square plus y square dy, where c is the boundary of area enclosed by x-axis and the semicircle x square plus y square equal to 1 in the upper half of xy plane. So the region is enclosed by the x-axis and the upper part of and the semicircle. So you will have the region, so this is the upper part of the circle, x square plus y square equal to 1, and this is the x-axis, so you have y equal to 0. So we need to take in the counterclockwise direction. So this is the required curve C. So this will be minus 1 0 and here you have 1 0. So this is the region R. Now we are asked to evaluate integral over C 2x square minus y square dx plus x square plus y square dy. So you are given an integral of the form m dx plus n dy. So by Green's theorem this can be evaluated as a double integral. So by Green's theorem, so integral m dx plus n dy will be double integral mx minus my dA. So you have nx equal to 2x varum and my is minus 2y. So therefore integral over c 2x square minus y square dx plus x square plus y square dy, that will be equal to double integral nx upon 2x plus y dA varum. Now you need to integrate over the semicircle. So here let me use the polar coordinates. So put x equal to r cos theta and y equal to r sin theta. So r will vary from 0 to 1 and theta will vary from 0 to 0 to pi varum. So this will be equal to, so you will get double integral, so that was 2 cos theta plus sin theta, r cos theta plus r sin theta and dA is r dr d theta, r square dr d theta. So 0 to 1, 0 to pi. So you get integral 0 to pi 2 cos theta plus sin theta r cube by 3 from 0 to 1 d theta. So that will be 2 by 3. Then integrate cos theta plus sin theta. So that is sin theta minus cos theta from 0 to pi. So that will be 2 by 3 minus 1 at pi. This will be equal to minus 1 alla plus 1 minus of at 0 will have minus 1. So that is equal to 2 by 3 into 2. So you will get 4 by 3. So that is the required value. So integral over C m dx plus n dy will be equal to 4 by 3.